Question number 54 CY 2022, and the question is the correct statements about group 1 metal is or are option A, reactivity of group 1 metals with water decreases down the group. Option B, among the group 1 metals the lithium spontaneously reacts with nitrogen to give red brown layered structure material. Option C, the thermal stability of group 1 metal peroxides increases down the group. And option D, all the group 1 metal halides are high melting colorless crystalline solids. Now we have to choose the correct statement among all these options. The answer might be one option, or it might be multiple options. Now coming to the answer, we will go through each options. First, option A. So what is option A? Reactivity of group 1 metals with water decreases down the group. Okay. Now we have to choose whether this option or this statement is correct or wrong. Now we have to think about periodic trends, periodic properties of group 1. So this is group 1. So what are the elements of group 1? First lithium, then sodium, then potassium, then rubidium, then cesium, then francium. Now francium is radioactive with half-life of 21 seconds. So we will omit this francium. We will not think about this francium in group 1 metal here. We will only think about the more stable and naturally occurring group 1 metals, that is from lithium to cesium. Now francium also appear in the nature, it's not like that. If we think about the group 1 metal from lithium to cesium, the natural abundance of sodium and potassium is highest among group 1 metal. Okay, but in case of lithium, rubidium, cesium, the existence in nature, that is natural abundance, is quite low. If you go down the group, the size of metal increases due to opening of new principal quantum number. Okay, the size increases along the group, that is down the group. Now because the size increases down the group, there will be less energy will be required to knock out the outermost s electron from group 1 metals. So the energy required to knock out the outermost valence electron is the ionic potential by ionization energy. So since the size of the metals increases down the group, so the ionic potential decreases down the group. charge is +1 in every case from lithium to cesium, but since the charge amount remain the same and size increases along the group, that is down the group, so with ionic potential also the charge density also decreases. And this value of charge density will become very much similar in case of rubidium and cesium because their size is very much comparable. The reason of this kind of similar size of rubidium cesium is the inert pair effect, F contraction and D contraction. Mostly, if you go down the group, the size increases, ionic potential decrease, and charge density also decreases. So if you think all these factors in mind, the hydration energy, there is an energy actually liberated while the metal ions is hydrated. So the process is actually, in that case, the process is exothermic. Energy is liberated. In case of ionic potential, we need energy, that is the process is endothermic. Here the process is exothermic. The energy will be liberated. Hydration energy also decreases down the group. So lithium, smallest in size, highest ionic potential, charge density among group 1 metals. Thus, it has the highest hydration energy. Since lithium has highest hydration energy, very easily it will form lithium hydride, lithium hydroxide, which form a protective layer on the metal itself, which in turn hindered the reaction between metal and water along metallic surface. The reaction is okay. The very easily lithium hydroxide is forming, and it is forming a protective layer on the surface of lithium. Thus, now the surface is protected because of lithium hydroxide. Thus, there is a less chance of reaction between the lithium metal and water. And since the hydration energy decreases down the group, decreases down the group, the chance of formation of this protective hydroxide layer is also decreased. Thus, actually, if you go down the group, it's less of this metal hydroxide will form, and the protective layer of this metal hydroxide will not be there to hinder the reaction between metal and water. Thus, if you go down the group, reactivity with water actually increases because of the not formation of this protective layer of metal hydroxide. So option A, which says that down the group the reactivity of the group 1 metals with water decreases, is wrong. Now come to option B. Option B is telling us among group 1 metal, Li reacts with N2 and forming the red brown colored compound. Now we already seen that lithium is smallest in size. This is one. That is one more, highest ionic. This is number 2, highest ionic potential. Since smallest size and the charge is same in every case, highest charge density among group 1 metal. So because of this fact, the lithium actually in reactions many times react differently than the other group 1 metals. It has very much similarity with the magnesium. We all know this phenomena, that is the similarity in reaction of lithium and magnesium, and actually they show some covalent character. By forming the metal lithium compounds and metal magnesium compound. Because of this covalent compound. Now coming to nitrogen. What is nitrogen? Two nitrogen atoms bounded by a triple bond of two nitrogen atoms are bounded by a triple bond. This bond is very strong. Since lithium has a covalent character, the smallest size, highest ionic potential among group 1 metal, and highest charge density, it has polarizing power. And because of this highest polarizing power, it shows the covalent character. These are interrelated along each other. Because of the highest polarizing power, it shows covalent character. And since because of this high polarizing power, it can actually polarize the electron charge density of this triple bond among these two nitrogen atoms, thus reacting with nitrogen like this. Only lithium reacts with nitrogen to form lithium nitride in the group 1 metal, and this color of this compound is, so option B is correct. Thermal stability of group 1 metal peroxides increases down the group, and option D, all the group 1 metal halides high melting solids. Now group 1 is lithium, sodium, potassium, rubidium, selenium. We will not think about francium. In group 1 metal, while reacting with oxygen, lithium only forms oxide, sodium forms oxide and peroxide. Potassium forms oxide peroxide and superoxides. Okay. And both of them mostly form superoxides. Thus, you can easily see, if you go down the group, the chances of formation and the stability of peroxide increases. The reason actually R plus R minus value of metal oxides, the R Li plus by R O2 minus only Li2 can form. This value is low. Okay, since the size of lithium is small and oxide size is, because of this fact, this small size, lithium only form oxide. And you can see from this group 1 metal series of oxides that if you go down, the chances of formation of peroxide is increases, stability also increases. The reactions are in sodium from peroxide and potassium, rubidium, cesium from superoxide. Okay, so since if you go down the group, the size of the group 1 metal increases, thus the R M plus value also increases because of increasing size down the group. The Rm plus by minus value also increased. And in case of oxygen, thus the formation of peroxide is increased down the group. So this option, that is C, is option C is correct. Now option D, all the metal halides are high melting solids, colorless. Colorless. Now color will appear. Okay. Color will appear when there is an electron transition between the orbitals of the metal itself, or electronic transition will happen from the ligand to the metal. It mostly color we will see in case of transition metal element, because transition metal has d orbitals. So there is a chance of electron transfer between different d orbital. In octahedral and other geometries, d orbital will be splitted in different sets of orbital. Thus there is a chance that electronic transition will happen in between the d orbitals, and because of the transition it shows color. And there is a chance of ligand to metal or metal to ligand charge transfer, that electronic transfer. In those cases also the color will appear. But since it is a group 1 metals, group 1 metal salts, the plus 1 charge, so it's completely filled. In case of group 1 metal, the possibility of the electronic transfer or electronic transition among the orbitals of the metal is not possible. Between orbitals of group 1 metal, because the electrons, the penultimate, that valence electron in case of group 1 metals are not RF orbital. Okay, are not in the orbitals. So since there is no chance of electron transition in group 1 metal, so this kind of color will not appear from the metal. Now the group 1 metal is highest electropositive. Metal ions is highly electropositive. Similarly, halides are highly electronegative. So there is a very much charge separation among these two centers. There is a very good ionic interaction between the halide ions and the group 1 metal ions. In case of this very high ionic bonding between the metal ions and the cations, the chance of electronic transition, the electronic transfer from the ligand to the metal is not possible, which is possible when there is some kind of covalency in the interaction between metal and ligand. In case of transition metal ligands, transition metal complexes, there is some sort of covalent character between metal and ligand, and along this covalent character the electron can be transferred from the ligand to metal, that is LMCT chance transfer, or from the metal to ligand, that is MLCT chance transfer. But this is not possible in case of group 1, since it is highest electropositive, highest electronegative. So there is a strong electronic bond, ionic bond, strong ionic bond between them. The chances of electronic transfer from one center to other, it's not possible. Halide ion it's not possible, and these two reasons they are colorless. Okay, colorless. And we know that because of this size, since the bonding between the metal and these halides are very much ionic in character, and the sizes of these metal ions are very much fitted for the crystal lattice kind of geometry. Thus, NaCl from FCC lattice, cesium chloride from, we know that, BCC lattice, this is structure, NaCl from FCC lattice structure, and CSCl from BCC lattice structure. Other group 1 metals also will fall in these two category of structures because of their sizes, proper sizes of the metal cations. Thus, the option D, that is all group 1 metals halides are high melting colorless solids. Since they have ionic bond along the in between the metals and the halides, because of this ionic interaction, to melt this compound very high energy is required. Thus, they are all high melting colorless solids, crystalline solids. So, option D also correct. Now coming to the options part. So this, from option B to C to D, these are correct, and only option A is wrong. So your answer is option B, option C, option D. Option is B, C, D. You will find the reference through the lecture on periodic properties, periodic trends and classification of main group elements by Professor M.S. Balakrishna, Department of Chemistry, IIT Bombay. Thank you very much.